planes overhead because Heathrow Airport and that. Well, I don't know. Either way, maybe I'll pinch the gain up just slightly. I'll try to talk relatively quietly today anyway, so a bit more gain should be good. Okay. Yep, all good. Ready to go. Check, check. Mic check. Go. Yep. Okay. Okay, welcome to Raft session 14, an entire 14 sessions because that's how long this is taking. Well, them's the breaks, I guess. It's not easy. Life on the estate is okay, I guess. The loud Chav family had well, the other day, I mean, just before I started one of my evening streams, they were having an argument about fraud. One of them did something bad, then there was a lot of shouting. And today, their children are beefing like some of the other children on the estate, and so they've been stepping in and sorting it out. You know, the usual like family insults and that kind of stuff. Yeah, okay, well, never mind. Where we are with the project, I would say we're done sketching. Well, okay, so I'm doing distributed systems, the MIT course. Pretty much all the information is actually just down on my Twitch page, the summary of where I am. That's all down there. But, yeah. What am I a bit drowsy today? Is it just what the weather is? I'll tell you what. Why not? Let's just start the stream with like a random weather check. Hang out and see what the temperature is. 26. Yeah. I mean, it's trying its best to drop to a reasonable level, but I mean, daily temperatures are about 30 degrees, and so they will remain. Oh, it's gonna chill out. It's gonna chill out on Wednesday. That's good news. It's gonna chill out on Wednesday. But for the time being, yeah, it's just 4 days of this. I've kind of preemptively decided I'm not gonna do any work tomorrow, just to give myself a break and try to fix my sleeping. I managed to oversleep an X-raid today. That was a bit strange in Pokemon Go. Whoops. I didn't think that would happen to me, but it was just 10 a.m. at this heat, and the struggle of getting to bed on time is still real with all the amount of stuff that I feel like I still have to do. My life right now is like, oh, I have to. There are like 16 people I should be messaging. Like, I want to message them, but it's just when it piles up to 16 people, things start to like fast get a bit ridiculous. So never mind. It's not something I should be worrying about. But yeah, that X-raid was a rip. I was never gonna get up on time for that fucking. That's a nice breeze. Okay. Let me get serious. I mean, what am I doing? I'm doing MIT's Distributed Systems project. Well, sorry, their course actually. I'm doing their course, and it has 4 practical projects, and so the whole point of this stream is I'm just going through these practical projects, these practicals, trying to do them without actually learning the theory, or rather, because obviously you have to end up learning the theory. I'm trying to just minimize the amount of studying and just make it very doey rather than study-y. So, yeah, I mean, lots of time so far. So I'm doing project 2, which is Raft, a consensus algorithm, a distributed system. And yeah, what a lot of it has been so far, because it's a 3-part project. It has 3 questions, and so I've done part A effectively, and now I'm finna do part B. Basically, what I've been doing is sketching, just a lot of making my own scrap notes. with my interpretation of what I should be programming, and it's gotten to the point where I just need to actually program it. So I'm trying my best to understand the theory as I break it down, turn it into a framework for how I'm going to implement things. Just as I do that, pretty much. I think the chav car is parked on a single yellow. Are you allowed to park on a single yellow? I still don't know. I still don't know what the yellow lines mean. I was never able to understand as a kid. Yeah, because I'm trying to think of strategies to kind of disperse them and get them out of the street and sort of in their houses / in parks, just so that there's a bit more peace in the neighborhood. So I'm thinking about how to do that. Maybe reporting the car is a reasonable first step. But I don't know what is a single yellow line. How does it work? I do not know. I still don't understand. Never mind. It's not a big deal. Let me not worry too much about that. Just tip the camera slightly. Okay. It's pretty difficult to get the right lighting at this time of the day, to be honest. Yeah. So that's it pretty much. We're ready to go. With actually implementing all that theory that I tried my best. I tried to understand it. I broke it down into this text, into these scrap notes, and this is up on my GitHub. The file is called 2b, and actually, thanks to a suggestion from a viewer in the previous stream, so I have to shout them out. I put in a README on the GitHub repository, so it's easier to navigate. You can find the files, and so 2b is my attempt to sketch, Raft project, which is project 2, part B. Part A I did, and I did a similar thing, sketched it, implemented it, debugs it, it works perfectly, which is good news. It's not going to be the most productive stream. The chavs are a bit uppity today, unfortunately. I think really what I want to do is find like a dog turd and just drop it in front of the window, because all they have to then do, I mean, I know it's hot, but in principle all they have to do is close the window, and the children are not going to accumulate around that corner anymore, and so I think problem solved. Possibly. Something to think about. I have OCD, so actually handling poos is not... Can't believe I'm even talking about it, but yeah, handling poos is probably not something it's really my forte when you have hygiene-related OCD, but it is an idea, and I can even see, like, from where I'm sitting now, I can literally see the gutter in which I would put the poo. So if I spot a dog poo, I will definitely have a think about doing that. Because no one's even going to be able to clean that up, they won't be able to spot it. It will just be a bad smell. Okay. I think that's a reasonable idea. Alright, anyway, let me try to not be so distracted, but if there's a random shout from outside again, then I will find it hard not to be. So as I was saying, my GitHub repository is now navigable, and so for each part I summarized. I tried to sketch it out and get a hold of the theory. There's a blueprint, which is bottom right of my Twitch page, which is the academic paper listing how this algorithm works. That thing, I tried to summarize into notes and try to get it as close to what I want to implement as possible, while at the same time trying to understand what it means. Why has it been designed like that? And with part A, I did that, and then I coded it, and it worked. With part B, I'm done with the sketch phase, so I'm about to start coding it. That's what today is going to be about, the actual programming. But I kind of had to give up on fully understanding it because it's too hard. So, like, I have a pretty decent grip on it, but a lot of the details I don't get. So I understand kind of some of the intuition about how it works, and I'll be able to kind of talk us through it as we go through and implement it. But on the whole, I would say I'm not down with the theory as much as I'd like to be. And even though kind of my systematic OCD nature is telling me, why don't you just try again? try for like the fourth time to go through it and explain it to yourself and make sense of it. Do like a fourth pass of sketch or whatever, or actually even third pass I didn't end up doing. And I've decided it's not worth it. You learn by doing, and I understand it well enough that really it's pretty reasonable to just start and see how far we get. So that's it. That's my preamble for what today is going to be. And so all good. I'm just gonna, after I kind of compose myself, because I've got like hay fever or whatever. Yeah, really stuffy nose. What I'm gonna do is blow my nose, and then I'm gonna send a message in the chat saying start. We are starting the actual programming. And once that is done, that's all good. So I just go through with that, and I'll be streaming for maybe an hour and a half today, maybe a bit longer, but I don't want to go too long because, well, reasons I'll explain in a sec. I just want to blow my nose first. I can barely breathe at the moment. Sad face. Oh boy, life is a struggle. Honestly, my throat and nose and all that has just never worked correctly, and so life is just a struggle. But it's all good. Let me just actually quickly, before I continue, I want to just make sure the camera's had a bit of problems getting focused and whatnot. I think. Let me just try. It's so delicate. I cannot talk while I'm doing that because um, moving my chest would just nudge the camera. Whoa, careful! Don't maximize or else it will freeze. Um, no, but I think this is pretty good, right? Yeah, in terms of focus and exposure and all that, it's pretty hard to get good lighting in the evening, but yeah, it's all good, and so I'm gonna push ahead. Uh, just minimize the camera. Try not to do that. So, I was saying, okay, why am I gonna work for an hour and a half or so? I'm thinking, recharge. Reason being, there is currently actually, if you're not feeling like watching programming and want to watch some fun speedrunning instead, I would suggest Zelda Speedruns, the sort of community group that sort of runs resources and things for Zelda in general. They're hosting a four-game relay race covering the 3D Zelda remakes. So, Ocarina of Time, Majora's Mask, Wind Waker, and Twilight Princess. HD or 3D, depending on which game. Um, and so I'm going to watch the Wind Waker segment of that because I like Wind Waker any percent. It's great. But the others, like they're going in release order, either of the original games or the remakes equivalently. And so they're currently on Ocarina of Time, which is some slightly longer category, but the others are any percent. And so about 11:30, Wind Waker should start, and I'm just gonna have a bit of fun watching that. Oh God, this camera stand is triggering me. Sorry, it's just not straight, and so it just kind of looks off to me. But let me just try to. Sorry about that. Wasting time doing that stuff because now see I'm not centered relative to the camera, but at least it looks straight. And if I just nudge it slightly further, by doing that, and then bring it a bit closer. Bloody hell. Ugh, okay. I'm just shifting my legs left and right pretty much to try to get it centered. Sorry for wasting time doing this. I promise I will be a lot more productive once this is all organized. I'm just gonna refocus the camera one last time. Okay. Perfectionism is so pointless when you're doing setting up like webcam streams and that kind of stuff. So, you know, stop me from just continuing to try. Because all I've done now is I've just made the camera not look centered again. Is it just because my posture is so bad? Yeah, I think my body is just snaking a bit, and that's why it looks so strange. I stretch out a bit and try to straighten up, square up. Oh, God, see, it's just on the side again when I do that. Well, actually, okay, this is pretty good, and it looks straight. It looks straight to me, and it looks straight on the camera as well. So yeah, that's fine. And it's out of focus again. Okay. Stop me if you've seen me do this before. Dear, okay. Well, in the VOD at least, I'll be able to say, okay, the first 15 minutes or whatever of this stream are a bit unnecessary, redundant, pointless. Okay. So yeah, that's my introduction for what we're going to be doing. Project 2, Raft, Part B out of ABC. We've done the theory. I'm not completely happy with it, that I understand why things are as they are, but I understand what I need to implement. And so hopefully just by working on the implementation a bit, I will be able to get a bit more intuition on what's going on. And so that's it. So I'm just going to get stuck in. Take my scrap notes for 2B, which are up on my GitHub. If you read the README, you'll be able to find my notes for 2B text file. So, without further ado, let's implement. Let's implement all that shit. An hour and a half of work or so. All right. Turn up the volume a bit. Right. I don't know why I'm in my perfectionist mood with the stream. It's really counterproductive. Okay, it begins. The actual programming. Oh God, I'm gonna have to like do Go again. It's been a few days since I did any Go. It's kind of like when I picked up JavaScript because my last JavaScript project ended in March. And I'm like, what even does like all this shit mean? Like, how do I type JavaScript? What am I doing? And all those conventions you have to remember, like using let in for loops and that kind of stuff. I'm like, but no, I haven't been away from Go long enough to start feeling like that, thankfully. So it should be quite smooth, I promise. I'm implementing part 2B, and that is split up, I would say, quite neatly into 5 bits of code that need to be implemented. Okay, so you can see them here. starting with group per data cycle, which is my sort of full rewrite of everything, starting here. My full rewrite of everything that I need to do and to implement. The latest copy of basically what's in my head when it comes to what needs to be implemented. So conceptually, this is organized into 4 phases plus one extra thing that is kind of unrelated to the phases. So I'll explain that before we start. The 4 phases are to do with the data cycle. I call it the data cycle. It's basically how data flows. So Raft is the bit that I've already done, part A, was all about the election cycle, so how elections work in Raft and heartbeats as a part of that. So now I'm finally dealing with data, which is to say, how does Raft transmit information that it gets sent? How does it replicate it on all of its servers? The leader sends it out to the followers, and then the followers have it, and when the majority have it, then the leader says, okay, cool, this has been validated, and we can pass it on back to the service that's asking Raft to get consensus on its data. Slightly hand-wavy explanation there, because I don't know exactly what Raft is for in practice. I haven't yet done one of the projects that elucidates that. Project 3, key value service based on Raft. But basically, as far as we're concerned with what we're doing now, data goes into Raft and data comes out of Raft, and there is a 4-step process that each piece of data goes through. And so I'm going to be basically implementing those 4 steps independently of one another. As well as the last part, which is updating what I've already done to make it compatible with another thing that I hadn't implemented before. So basically, I hadn't implemented logs at all, because logs are basically where data goes, you know. Each server has a log that aggregates data. And because I hadn't put the logs in, because I wasn't doing anything to do with data, there's a bit missing from how voting is determined between Raft servers. And so I just have to add that in independently at any point. Once I've put in the log, I can add that in. But these 4, so that's the vote request section, because the RPC I need to edit, the bit of code I need to edit is vote request. But the other 4 are the data phase, as I've just described it, and that's in, so it's in, write, commit, and out. So the in phase is how data gets into Raft, and the out phase is how it gets out. And once data is in Raft, it needs to be written. So what that is the leader receives the data, adds it to its own log, and then it needs to get the data out to all of the followers, all the other servers in the cluster, which are followers. And those servers need to have also written it. That's the write phase, and write is all about getting the information out as soon as possible, and also making sure that nobody's log conflicts with the leader. And so we have things like that. So, you know, this is how the leader sends information to followers. And then what the follower does is it merges logs, which means if there's a conflict, it fixes its log, and then it adds new entries to the log. And that's basically the whole write phase. There's not that much there, really. And then once everyone has written a particular piece of data, there has to be a strict majority that has written it. So we're allowed a bit of failure in some of the servers. But if a strict majority has written it, then the leader commits. And commit is basically saying it's ready to be sent out. But everyone needs to know that the data is committed. And so this is all about how the leader tracks what should be committed and how the follower tracks. Spoiler, leader tracks based on figuring out who has successfully received the stuff it sent out in the write phase. And the follower commits basically just based on has the leader committed yet. And then the out phase is all about how it gets sent back out to where it came from. Well, like, I don't know why Raft is necessary for anything. I don't know why things are sending it data and it's sending data back. But basically, yeah, from the internals of Raft, this is what we're doing and this is how it works. So it splits up neatly into 5 phases that I'm going to code. I'll see how many of them I can code today. Probably not all of them, it's a lot of work. But also, we need to put in the state variables. I don't have all of the state variables there yet, because I wanted to, before I coded them, I wanted to spend some time figuring out what the point of them was. So I have a decent idea of what the point of all these state variables is. And I'm ready to just kind of go for it now. So the first bit is implementing the state variables, which is really just a case of writing down some things, a few variables, a few containers. The variables are just kind of there, but we're not doing anything with them until we start implementing the 5 phases that I was talking about. And so that's both state variables in the Raft server, how Raft maintains state, and it is also just their variables that go into the RPCs that I haven't put in yet. So a bit of that stuff. This is just some commentary, and okay, that's it. That's basically everything. So without further ado, let's go. So I'm going to put in a note that I'm about to start 1 out of 6 add variables. So it begins. It begins with some variables getting added in. Sick. Well, I say that. It actually begins with me checking that the camera's kind of okay. Yeah, camera's not too bad. It's kind of passable. Okay, let's go. I want to try cutting down on my umming. I know that's because it's kind of loud compared to my normal speech when I'm just kind of grungily, groggily, mumbling my way, like with this kind of monotone that kind of emerges. And then I just, out of the blue, I just go, yeah, that's what I want to cut down on slightly. But you take the point. So let's do it. Phase 1. Begin. So these are the 4 files. Let me just, I'll quickly, this is all, I've written a few pointers as to what's what on my GitHub repository. But basically, source code, the source folder, and Raft is where all of the Raft stuff goes, basically. I do know what all these folders are for. I spent some time figuring it out. And Raft is the only one that is relevant to us for this project in terms of what we code. So these 2 lab folders just give us a couple of routines that have been included by MIT to help us do RPCs and that kind of stuff. Because RPCs are simulated; they don't use the actual RPC protocol in the Raft project, which is nice because it makes it compatible with Windows. But at the same time, MapReduce, you did use the actual RPC protocol, and it wasn't hella not compatible with Windows. And so I've already been through the 6 or 7 plus hours of getting it to work, which for Raft is just completely wasted. But at least MapReduce is done now. I can forget about it. So that's what these 2 are for. I can't remember what linearizability is for, but I'm pretty sure it's not relevant to Raft. Main and MapReduce are both relevant to the MapReduce project, so that's finished now. Main had a bunch of other crap in it as well, but I've just cleared it out because basically projects 2, 3, and 4 in MIT's course are newer than project 1, and so they have different conventions. And so the main folder is only used by project 1. Largely because I deleted everything that wasn't used by project 1, because it's literally stuff that is left over from old projects that wasn't deleted and was just causing bugs in Visual Studio Code, warnings and things. Basically, it was ridiculous when I figured that out, but it's all good now. So that's what these 3 folders are for. That's what these 2 are for. That's project 1. Raft is project 2. KV Raft is project 3, and shards, the 2 shard folders, are project 4. I'm pretty sure. So Raft is the only one we care about. This is some old debug information. I'll tell you what I am going to do quickly before I actually get to work. I'm going to test that I haven't broken anything, because I did a minor bit of code refactoring just as I was kind of discussing stuff. So I'm going to do a debug off test. So debug gets set to off, and then I just test it by going go test run the 2A, so part A tests. I'm just going to run them here. But because debug is off, it's not going to print any of this the usual garbage that it prints. It's just going to go passed and then passed. Good. Just to make sure, because it does depend on RNG slightly, I'm going to do it again. But yeah, basically. So I've just edited. Yeah, so the Raft project files themselves are pretty easy to get your head around as well. The only ones that matter are these four here. So from Raft flow to RPC request votes inclusive. Persister is something that I think needs to be is relevant to part C, but not relevant yet. Debug is just literally my debug function, which is called P. It's a print debug function that can be toggled on and off here. Config is just some test routines and debug routines. See, it uses the lab RPC implementation, which actually uses Go channels rather than genuine RPCs, which is cool. And the test file, which has all the tests that I'm trying to pass. So basically, I succeed if I pass the test, pretty much. But I've also gone further than that. I've made sure that the code, like, genuinely does what it's intended to do according to the academic paper, because I think that'll make it more reliable in future projects. So, okay. Sorry, that was a bit of a preamble, but basically these four files are the ones that matter. Raft itself contains stuff that is relevant to the interface of Raft with the outside world. So this will be getting edited for the in phase, possibly the out phase, but I think probably not the out phase. I'm not sure. But basically in and out. The internals here, Raft flow, that contains all the leader codes, the follower codes, the candidate code, and so it's going to contain all of the random headlight flashes outside. All of the codes for the write and append phases, and not all of it. Some of it pertains to the append entries RPC, so whatever that is goes into this file. And request vote is the last phase that I talked about. That's outside of the main data phase. It's just some modifications I need to do to request vote. That goes here. So that's basically that. So you'll know, depending on which file I'm touching, what I'm going to be editing. So as I said, now I am doing 1 out of 6 add the variables in. So what that pertains to, well, the variables I need to add, some of them are append entries data, so that's going to go here, and some of them are state variables, and that's going to go here. So I may as well just do that now. It's not going to take long, because all I'm doing is typing in the actual state variables themselves. So I'll show you. Basically, there are so many comments here, I can barely find stuff. This I should probably delete at some phase, but I'm pretty sure I'll just delete it now, because I'm pretty sure I've implemented print debugging properly now. Okay, apply message. This is to do with the out phase, but it was also just kind of there already in the code. I don't think that's going to need any changes. These are some variables that specify timeouts, mostly relevant to part A. And here we go. So Raft, the struct, this is where all the state variables go. Okay, I'm looking at it now. I've actually already implemented the state variables. I'm pretty sure this is all of them. So let's take a look at the blue. No, actually, I don't need the blueprint. In my scrap notes, I have the state variables. Log, commit index, last applied, and if it's a leader, it has next index and match index. And here they are. Log, I don't know what type the data has, but I've just put it string because that's a kind of good general type for data in general, like serialize the data, for example. Commit index is a monotonically increasing natural zero number, I think, hence integer type is good enough. Last applied. Oh yeah, last applied is another variable I haven't. Oh yeah, here it is. It's another. It's the same thing. It's based. Last applied is basically apply index. So commit index and apply index. So I described the data phase as being in, write, commit, out. Basically, in is just okay, the data gets added to Raft. Write is the write phase, commit is the commit phase, and out is also known as the apply phase. So commit index tracks what's been committed, and apply index just tracks what's been applied, i.e. outed. So yeah, that's fine. And next index and match index is just an array of integers. In Go, you can actually specify the length of an array, and the length of the array is supposed to be the number of pairs, but I don't think I can statically, outside the function, specify lengths of arrays. I'll show you what I mean. So I cannot go I can't go len pairs. Oh, I can't do that. Not just because of that, but also because pairs is being defined in the same struct, and so it's telling me that it's undefined here. Okay, fine. It's not a big deal, but it is worth remembering that these two, next index and match index, are of length, and the indices correspond to the pairs array. So basically, it's the pairs are all of the servers, and they have some like RPC addresses, as you can see here. And the array of those, which pair is which, is identified by the index of the pair in this array list. And for example, me is myself. It's my index in two pairs. And next index and match index, the indices correspond to the indices of the pairs in pairs, and the values correspond to, well, what the next index is of that pair, what the match index is of that pair. Okay, so that's actually done. I already did that, I didn't realize. The other thing is append entries, the structs in append entries, these two. Well, they also have, I've already put in all the data for those, haven't I? Prevlog index and prevlog term, those are both have type unsigned integer, effectively, but it's conventional to call them integers, even though they are strictly unsigned integers. Natural zero numbers is the math way of saying that. Entries is the payload of data, so that's like a slice of log, so it's a string array. Leader commits is the sender's commit index, which is again natural zero number type. And the reply, is that everything here? Yeah, because term and leader ID were already implemented. And the reply is just success, which is no longer is sender up to date. Success has a strict definition that only applies to append entries. The whole is sender up to date thing is something that I used to call success, but then realized it was actually strictly it's to do with well, it's not to do with success, but it's kind of an extra thing, which is, should a receiver of any RPC respond to the sender, and there's a condition that depends on term, which is election term. Basically, the higher the term is, the more up to date a given server is, and so comparison of terms gives us this: should the receiver even respond? Because if the sender is out of date, the receiver should just err it, blank it, ignore it. And so basically that's that. Sorry, I'm finding it very easy to lose track of my thoughts. I'm sorry. Um, But yeah, that is an extra condition that I defined as a result of that, and I call it term sync react now. So term sync is all about syncing terms up, checking who's up to date, and react is a variable that I have in all of my RPC receivers, where the entire function of the RPC is actually contained within the React bracket. So all this stuff is just trivial. This is just checking the terms and comparing them, and all RPCs do that. And then the thing that's actually specific to append entries or the other RPC request vote, that goes in the if React, because if React is false, that means we should not even be replying to this RPC. We just drop it. Yeah, my throat is a bit. Well, actually, yeah, we finished. I mean, the thing that I said is part 1 out of 6 of this do phase, which is put all the variables in. I've already done that, so that's finished. I didn't realize I'd already done it, so I'm gonna actually start the I'm gonna start the actual coding now with part 2 out of 6. First though, yeah, I'm really struggling with my throat. Maybe I just need to talk a bit less, because breathing is hard when you're talking so much. But yeah, okay. I'll do a kind of quick 1 minute chill, and then I will start part 2 out of 6. So I'll just blow my nose quickly. Do you know, I really regret not bringing in a water bottle. That would have helped. I guess I can just go and get some water, but for the time being, I'm okay. Just kind of allowing it. Just kind of get some oxygen. Water is okay. I'll deal with that later. Okay, so that's that. Let's get on with it. Let's actually do the first of the phases. So, in phase. Okay. Yep. So yeah, ready to start the in phase. Easy enough. I look at my notes, jump to what I said needs to happen in the in phase, and basically just implement that. So the in phase is something that the leader does. Well, actually, it's something that everyone does. Is it handles it the entry point into this whole sort of conceptual code system thing phase? I don't know. Basically, where it all begins is with the start function, which is in Raft.go. So I was just looking at the Raft struct. There's a get state function that pulls state out. Persistence is part C. I'm not doing any of that stuff yet. Start. Here it is. So we actually have quite a lot of scrap notes here. I've already read them, but I mean they're pretty basic. It's basically just saying like, if this server isn't the leader, it just returns false and does not do anything. Um, so index, term, and is leader need to be actually set to something. Let me delete. I think I put in some default values here just to get rid of warnings. But in principle, yeah, I haven't actually decided what all this stuff is. Basically, yeah, as it says here, if this server isn't the leader, we just return false and don't do anything, right? Otherwise, we start the agreement and we return immediately either way. If it's we return, well, when it says return false, I mean what it actually means. If you look at the return signature, which has not actually been fully described, It's not actually been specified here because there was some sort of bug in the Go warning system that meant that I couldn't specify the variable names here for some reason. But basically, this is index, this is term, and this is leader. And so isLeader just returns true or false. There's actually a function, I think, that automatically checks isLeader. It's called getState, right? So I can literally just use that. So, this introspects into something I've already implemented. It's kind of a quick helper function that just checks the state and the whether or not the peer, the server that's running it, is in the leader phase. Because don't forget, there isn't just one leader. All the servers can be leader. They change from leader to follower to candidate, and candidate is the thing that becomes the leader if it wins enough votes. That's the basic kind of cycle of how things work. It's a leader, and it sends out messages, and every time a message is received, that thing becomes a follower, stays a follower. The other server stays a follower. It's just when it stops receiving from the leader, that there's a timeout that goes off, and it becomes a candidate, and then it requests votes and things, and if it wins enough votes, has a majority, it becomes the leader, and then the cycle resumes. It's kind of that's the simplified explanation of the election cycle, which is there's a lot more subtlety to it, but that's part A. No need to talk about that. So yeah, the phase, isLeader is the phase. Whether or not the phase which is either leader, follower, or candidate, whether or not that's leader, and term just checks what the server that's running it thinks the current term is. So it's pretty easy to just do that. Basically, term and isLeader can literally just be pulled out of getState. Does getState have any arguments? No, it doesn't. And that then, because all code is synchronous in Go unless you tell it not to be. All code in Go is synchronous unless you tell it not to be, which means that this actually will hang up the code and run the getState to check state and then return these two variables. So it's, what is it saying here? Unexpected, yeah, that just means that this hasn't been implemented. So, okay, let's implement that. Do we know what index is? It says index that the command will appear at if it's ever committed. First return value is the index that the command will appear at if it's ever committed. Yeah, the second return value is the current term, and the third is whether or not the server is the leader. So those two are just introspecting the state variables, and we have a function that does that. Done. And index, I'm not actually sure yet how that is going to be implemented. I'm going to have a think about it now. Oh yeah, getState is part of RF. You have to. Everything belongs to the RF Raft object because I don't know, convention. Doesn't matter too much, but so to summarize how this function works, it returns immediately, but it also asynchronously runs some codes if isLeader happens to be true. So as you can see from the way it's been structured, the way I've written it, this immediately figures out index, term, and isLeader and returns them. So it immediately returns, but it asynchronously will run isLeader. It will launch isLeader. It will launch. The way that I'm talking is just. If the thing is leader, it will launch some more code where it does something, and that's what this pertains to, right? So here it is. Otherwise, i.e., if the server is the leader, start the agreement. But in both cases, return immediately. There's no guarantee that this command will ever be committed to the Raft log, since the leader may fail or lose an election. Even if the Raft instance has been killed, this function should return gracefully. And this function always does return gracefully because it returns immediately with some data. So I don't really know why they're talking about graceful return. Okay, what's worrying me about this is that I don't actually know how to figure out index. It says here, the index that the command will appear at if it's ever committed. How am I supposed to figure that out? So, do I introspect the leader, find out how big its log is, and then depending on how big the log is, just assign the next value? Is that what I do? Because there are no global variables. How else can I know the index? That's something that's confusing me, to be honest. Do I have anywhere where I can look up a bit more information about this? Well, I guess the go-to is the Raft's project page on MIT's website. So it'll be good to just check that out. I've already read through the actual stuff on part 2B. I've already read through that. There wasn't really anything interesting here. It's just telling me what I already know. I'm implementing start for the in phase, completing append entries, RPCs, adding some stuff as well. Yeah, both the data and the handler, the receiver function. And when it says advancing the commit index at the leader, it's not just that. There's some other stuff, but there's something the leader just needs to be always on top of. That stuff I already know. We'll get to it when the time comes. But yeah, I wanted to know if there was anything, any information on how I should figure out what the index is. Where the commands will appear if it is ever committed. We don't have a way of knowing that, surely. How is it possible to figure that out in advance at all? That's what I don't know. Because my thinking is like, we can look at the commit index, what's already been committed and applied, we can introspect those, but that doesn't account for new data that's in the process of being committed. But then if we look at that stuff that is volatile and might not end up committed, which, to be fair, it does say here if it's ever committed, so there's possible it won't be. But surely we can't then assume that the next data goes in that particular position immediately after the data that we're currently working on, before it's been committed, because that could change. If one fails to be committed, then the index should be lower by 1 for the next thing, even though this function has to handle and return the index before the commit has finished on the previous piece of data. Not much I can say about this, to be honest, other than I do not know what's going on here. I'm just going to set this to 0, which is the kind of, because all the indices in the logs are, it's 1 indexed, and so 0 is kind of like not applicable or whatever. It's a good placeholder value. So I'm going to just leave it at 0 for now, but put in a nice triple question mark to say this is wrong and needs to be sorted out. Actually, it's probably wise to put this in the to-do list. I have a little to-do list here. This is just from 2A, another thing that I wanted to do, but I think, honestly, syncing votes to terms is something I should look at, but it's not important because I think it works. And I think I'm being paranoid by even putting that in my to-do list. So I'll just put it as a kind of maybe later. But yeah, to-do list. Start should return an index. Who knows? Who knows? Doesn't matter. Listen, we can just skip that because I do not know what's going on there. We'll probably think of something as we get on with doing all the other stuff. So, if the thing is a leader, it needs to do something. What does it do? The answer is actually fairly simple. It actually says it here. So, you know, follower immediately returns, starts, yep, and leader does the same, but it also does something else at the start phase. And this is literally the only thing it does. Data input, i.e. append to my log, thereby increasing last entry index. You know what? Look, basically, whoops. What I'm going to change I want the to-do list. I want to change this to check the index return, because guess what? I have a theory for how I should implement index, and it's pretty simple. Basically, is leader. What that does, the only thing it needs to do is append the latest piece of data to the self's log, right? So if I am the leader, I just need to append the latest piece of data to my log, and then this function returns, and the rest of the code then picks it up. Even though I'm not triggering any new code here, all I am doing is appending to my own log, and that's what it says here. Because it's not a cascade, it's more like, if it's in the log, then something will detect that it's in the log later on, and that's how the code resumes. As opposed to cascade, what I mean by that is like, okay, one function calls another, and that's how things move. But concurrency is mostly about avoiding that kind of thinking. I have found. I don't know if that's sensible. Yeah, so that's cool. So I am actually going to return an index after all. This is how it's going to work. Well, when it says your code here, I may as well just, you know, dump everything under that. So first it figures out term and is leader. Then it should figure out index. Okay, let's do that. Let's figure out index. To figure out index, unfortunately, we have to log. Do we have to log? Can we not just modify get state to return the index? I think we can do that, and we may as well do that, to be honest. So it's going to return current term, whether this server believes it is the leader, and index length of log, basically. Do we want length of log? We want the so this is a bit of off by one error type convention, because the log is one indexed, but of course arrays are always zero indexed, or lists or whatever. That means the length should be defined as not the length of the array, but the length of the array minus 1, which means that the length is in fact the highest index present in the array. And that's intuitively what the length of the log should be, even though it is the length of the array minus 1. Yeah, I'm just going to put that in for clarification. So it's going to return int ball int as a result of that. This edit in the signature actually messes stuff up in the config. But at the same time, because the lock is here, I think it would honestly just... This is all about introspecting ahead of running the starts function, and so I really think that I should just change get statefully so that I only have one lock, because logically that is one introspection that I'm doing. I'm just getting 3 variables out of it. So yeah, I mean, I couldn't tell you about that, to be honest. What I'm gonna do is try to I'm going to try to put the titles of the names of the variables in the signature, because I just think it's cleaner that way. So when it says return 0, term is leader, that should be return term is leader and log length I'm going to assign here. It's the length of the RF log -1. Slightly itchy eyes. So that should all be fine. Now Raft.go should not have any errors in it. I will just immediately go ahead and assign variables like that. Yeah, just be careful, index should actually be one higher than that thing. So yeah, then just delete this, reassignment, and I don't need the variable names to be after return because I've put the names of the variables in the function return signature. So this here is leader is type int, which is wrong. Wait. You got to be careful. So the first return value is the index. My bad. The second return value is the current term, and the third is the is leader bool. Okay. Yep. Carefully does it. And so yeah, sorry. Yeah, there's a mismatch here because the order is all wrong. God, I feel like I'm making some fairly major changes at the moment, but I think it is just for the best. Now, I'm going to do it like this. Term is leader and log length is equal to rf.getState. I think that's fine. Log length now needs to be defined. And so we then just define index to be log length +1. So we have so we basically just have a bit of a distinction between what is what. So this is literally just matching the information we get out of getState, and then index is it's not actually just the length of the log. It's going to be that +1 because that's where we want the next piece of data to land in principle. Right. So this is why in my to-do list I said, okay, check what you're doing with the index, because I'm not sure that's what the index should be defined as, but it's the best I can do for the time being. It's my best guess, and so I'm going to push ahead with that, and I just put it in my to-do list that I should check that that's all Gucci at the end. And so yeah, I managed to put I don't know why this failed last time I tried it, but it's succeeded now. I managed to put the actual names of the variables in the return signature of the function, which just makes it a lot clearer how the function interacts with the outside world. You just need to read the first line pretty much, and you immediately know. So that's why I did that. I'll just budge up slightly. What? Okay. So those camera flashes whenever I move the camera about a bit too much. Temperature is 80%, fairly reasonable. I do need to, I think, improve the flow of air down at the bottom of the laptop. It's a little bit constricted, I think, because it's really like this hinge that I need to get the air into, isn't it? pretty much, yeah. Optimal conduction. Okay. Yep, so that's that bit done. And yeah, like I'm saying, with if is leader actually happens to be true, then yeah, I guess here I just have to do the lock and the unlock. Do I remember how to append stuff in Go? No, I do not at all. So go lang list append slice. Slice and list are synonymous. This thing equals append that and God, yeah, the syntax is just stupid. I'm not gonna lie. Does it make an entirely new copy of the You can't in place append to a slice, or can you? No, I think Go is fine. It doesn't actually do any copying or anything. It runs the append. Oh yeah, no, sorry. Go is a bit, Go is a bit of a space age language, to be honest. It's not entirely. This is gonna have a fucking type mismatch. It's saying here cannot use. Okay, so commands have type interface, so the arbitrary type in Go. I think this is just boilerplate for some sort of arbitrary type that literally anything can fit into. But I'm calling it string. Okay, so basically I just need to quickly change my data type to always have this arbitrary type. So log, and also in append entries this as well. The type is arbitrary interface. So basically I just edited the type of the lists that contain commands. So entries that are sent via append entries and the Raft logs themselves, because the stuff that goes into them has the type interface with curly brackets, which is a arbitrary type that anything can fit into. That's what that is. And because Go is strongly typed, so the lists have to have that type as well. So I just fixed that now. So this is all good. Yeah, I was going to say about how Go works. I do remember now from reading the tutorial. The underlying array exists in memory. And what happens here is that not only do we have the array, but we also have a slice, which is just kind of a pair of integers specifying start and end positions in the array, or maybe even just memory addresses. But the point of that is that those are cheap. So when we do an append to one of those, all we are really doing is editing the underlying array. So we take this, which references the array. This actually references what in Go is called the slice, which is the little pair of numbers or memory addresses or whatever that specify bits of array. Slices of array are kind of specified by this slice type. And so this is a reference to that slice. Then we say, okay, to that we append command, which means we go into the underlying array and add command to it. And then setting rf log, that returns the slice that contains, that is the rf log slice extended by 1 to include the new bit of information that's been added to the underlying array. And so that is now what is returned by this. And so we assign that to rf.log. That means that we update rf.log to point to that slice. It makes sense, but it is kind of unintuitive. And certainly the first time you read about how slices work, it's a bit, I don't know, not like any other language I've seen, but it does make sense, and it does mean the append syntax is a bit stupid looking, but there it is. That's it, done. Oh yeah, something I've I've forgotten to do that. I told myself I'd get back to doing immediately, but then put it off. So get state, I edited the return signature, which means that I just have to go into the MIT's own files and just edit the interface with this particular function. So I'll just do that now. Basically just by putting in a placeholder, a dummy variable here that says, this underscore just means ignore this thing. So getState returns 3 variables at the same time, and the underscore means I don't care about the second one and the third one, I just want the first one. And that's in general how underscores work in Go. They preserve the positions, but it means that you can kind of get things that return multiple things at the same time and use them quite elegantly. So it is term, is leader, and index and log length, and that has to be the structure just for maximum compatibility, for me not having to change too much stuff. So yeah, that's pretty simple. That's just some pretty trivial changes, and it's also easy enough to revert this, even though I do feel a bit booky about editing the actual lab files that MIT provided that shouldn't be edited, but it's minor enough that I'm not too bothered. Yeah, just that minor edit to get state working. And later on I might just decide when I'm finally testing it to change get state, refactor the code so I'm not even using get state. And instead of that, just put all the code in manually again instead of whatever this function is. And then just reverse everything by, pulling like original copies of the MIT repository on all of the files that shouldn't be changed, so the tester file in particular, and then retest using that just to make sure I've actually done it all correctly. It's just kind of astute to do that if you're actually submitting coursework, and so in my case it's just kind of okay, a strict requirement. I've definitely done this correctly if I've tested it against literally the original test. But for the time being, I'm just making what I know in principle are trivial changes that are not going to actually affect the tests. But if they do, that will be caught when I go back and do the final test using the original code provided by MIT, the original test code. So okay, that's all good. That's it. I've done the in phase. The in phase is finished. It's pretty simple. As you can see, this is all that I've done. So, oh shit, wait. Oh no. This is fuck. This would have been a big mistake if I'd. You always have to lock and then unlock. This whole block of code needs to be run asynchronously. That's something I said already. It's kind of trivial because all it does is append to a list, and that's fast. But at the same time, because it requires a lock, that's got to be asynchronous. So let's just do that now. There is a really quick and easy piece of boilerplate where you define an anonymous function with trivial signature. So by trivial signature, I mean no arguments, no return values. What did I do? Control X plus. And in that function, I just put the stuff that I want to be run asynchronously. Expression in Go must be function call. Yep, that's just because this is the function declaration. But because Go is a function call, Go takes a function call. That means that I just need to call my anonymous function. And what Go does is it starts it in a separate Go routine, i.e. basically a separate thread for all intents and purposes. Go routines are lightweight threads. It's an abstraction of a thread, not the real thing, but it's probably better than the real thing. Even better than the real thing. Even better than the real thing. That's a song I liked in 2011 before I realized I was wrong. Wow. The remix that U2 put out in 2011 of that song had some pretty cool stuff in it. It was just kind of, they dropped the ball on the production a bit, but it has some cool ideas, and I really liked it as a song. I thought it was powerful. Not the kind of stuff I like anymore, because it's a bit melodramatic. But at the same time, it had some good like rhythmic dynamics and things. And I'm just sorry, I just started rambling because I just started remembering what the song sounds like with the octave pedal and the textures and that. It's a pretty good song. I mean, I shouldn't be too harsh on it. Yeah, so just U2's Glastonbury 2011 performance, the first song, visually quite spectacular as well. If you're interested, take a look. The rambling, man. I'm just like, I don't know, feeling a bit uppity for some reason. Oh, God. So I don't know why I feel so weird today. To be honest, I'm just kind of, yeah. Hopefully, I can take a break and feel refreshed later on. Maybe I'm just a bit self-conscious. I don't know, but it's fine. Never you mind. Let's just take it easy. Let's just be chill. Um, cool. So this is my asynchronous do the actual append, and that's what I said that I needed to do here. And because this is asynchronous, it returns immediately, which means that this function returns immediately. It doesn't return immediately because it has to do a get state to pull state. But that's pretty simple and fair enough. I think there's no way of avoiding. If you're going to actually read state, yeah, you have to lock somewhere, and so get state does indeed contain a lock and an unlock, and otherwise it just reads some variables, so it's pretty simple. Yeah, so I'm happy for that to stay as it is. This is, again, I don't know if this is right at all, what the index is, but it's fine. And if it's the leader, it does the append. Okay, so that's that bit finished. The in phase is done. The in phase is pretty trivial, to be fair. So yeah, you can see the right phase is pretty long and winding, isn't it? I'll tell you what. I'll try to do the right phase today. I have another half an hour. It's the meatiest bit of what I'm doing is the right phase, so I'm thinking about whether I should actually take a crack at it now. But to be fair, I am not debugging yet, so if I just kind of implement it vaguely as I think it should be implemented. Or do I just kind of stay chill and implement some of the later phases just because they're a bit easier? Honestly, I think that's what I'm going to do. Yeah, just because I fancy myself feels getting a bit of rest before doing. This is, I think, definitely the hardest bit of the implementation. Well, it's certainly the longest bit, and that means there's the most chance for something to go wrong. So, like, clearly, yeah, watch out. Um, hmm, I'll tell you what. I don't know. I'm just really feeling. I'm feeling slightly not myself, and even though I could probably work a bit more and a bit harder, I'm feeling like I want to just leave that for a future session because I'm just not feeling that up to it today. Don't feel like I can really be myself. So what I'm going to do instead is, so I've done, yeah, the state variables and in phase. What I'm going to do now is this phase, the vote request phase, because I'm pretty sure that's easy. And I know where to implement it as well, which definitely helps. It means I have to make fewer decisions. The challenges that are going to come up in some of the other stuff are going to be along the lines of so these tracks things, which need to be constantly going, these are probably going to need timeouts and things so that they don't block the entire system, the entire like event loop. Um, So that's something to think about. And another thing is just like if you can see here that well, for starters, there's a lot of like editing logs and things, and that's quite complicated. But it's not just that. It's also here, for example, in the commit section, I have to like figure out how to find existing ends, which means maximizing things, and it requires a bit of optimization, basically. So that's not gonna. It's not immediately clear how to do it straight off the bat. Same goes for this one, which yeah, just I need to figure out where to implement things that everyone is keeping on top of. Where in the code does that go? Vote request, no such problems, so I'm just going to sit down and do that. So hold tight, vote request. Hold tight the vote requests. So let me just type in this comment here. You'll see the comment in a second in the Twitch chat. Yep. So let's just do that. Let's just update vote request to get it working. So basically, vote request. All that is about is that I'm saying in vote request in my receiver of vote request, the payload section, which is to say where a server decides whether or not it should give a vote to a different server that asked for it via the request vote RPC. There's an extra condition there, which I've written here. Vote should also depend on log updatedness, and so we need to do log comparisons. And so I'm quite happy to just do that here. I think probably the easiest way to do this is just with a nested if block. So in the original theory of how this works, the vote condition is basically number one, react has to be true. So should I even be reacting to this request for a vote? Answer is no in cases of the thing that's requesting is really out of date on term. So that's the trivial condition because that applies to both of the RPCs. Test 2 is have I already voted for someone? So if not, or if I've already voted for the same person and it just needs another validating vote, then that basically. So it's just checking that it doesn't vote for different people in the same voting term, and voting term gets reset. Voting term increasing resets voted for, it nullifies it, so this would become true on the next vote. That's the second condition, and the third condition is the log updatedness test. So do you know what? I'm just going to put in a nested if block because I think that's the cleanest way of doing it. First of all, we need to run the log updatedness test, okay? And that's well, the information we need is here. So this is what the test is, okay? So I am looking at my own log and I'm looking at the thing that sent a vote request, its log, the candidate's log and my log, the follower's log or whatever's voting, candidate and voter, basically. I'm comparing their logs and the order relation that I'm using is basically last entry. So the last entry, the term that is attached to the last entry in their log, the most recent entry, that's the first test. So the later one of those, and if these are equal, then whichever one just has the longer log wins, basically. And if those are equal, then this returns equality. But the vote condition, according to my notes, which I hope I've done right, is that it's a non-strict inequality is what we need for this to vote true. So let's settle that then. The information we need is the last entry's term and the length of the log. Those are the two bits of information that we are testing. that make up the definition of this order relation on log updatedness. So first of all, what I want to know is, has the candidate sent that information over? Because I can introspect my own last log entry and term and whatever. But can I introspect the candidates? And the answer is yes if the candidate sends over the information. And so here is what the candidate sends. Last log is sending over last log term, which is one of the things we do need to check. But the other thing we need to check is the length of the log. Well, and this is sending last log index. Okay, and index and length are the same basically, because the index is exactly the index within the log plus 1 because it's one indexed. No, not even plus 1, it's one indexed, but there's a 0 in the obvious place. So it is literally just the index within the log array. So last log index and last log term are both sufficient for us to do the test. So let's do it. So first I need to introspect these variables for myself, which means I need a log. Oh, but I already have the log. Sweet. So all I need to do is figure out my own entries. So there's a bit of an error I've made actually. So it's just occurred to me. So I'll type my sentence here and then I'll explain what I've just noticed. So my sentence here is just like, oh my god, my butt is just slipping so much. Move the camera down. Silly, innit? Butt slip. Yep. Okay. Sorry. Yeah. So, sorry. Oh god. Yeah. I keep messing this up. I want to just check that my camera is moving and check that the microphone is reacting to my voice, and then minimize Streamlabs. It's just when I don't do one of those three things correctly, it just confuses me and I get paranoid about the stream going down. What I want is to take a look at my log and take a look at the last entry of my log. How do I get the last entry out of the log? Go slice last element. That's what I want. How does it disappear whenever I type a letter? That's ridiculous. For just reading the element, use this slightly ugly notation. Length -1. We'll have to do, I guess. So yeah, my last entry is going to be this. I just realized that my last entry needs to... It needs to both contain the data, which is the arbitrary interface type, and it also needs to contain the term. So I need to define a log entry type struct to contain both the term and the data. And not only that, I also need the index, but that's just the index, so I can get that another way. I don't need to store it in the list. But yeah, basically it needs to start looking like this. This doesn't throw an error, believe it or not. But I'm gonna go back and sort that out in a sec. So my last entry term is figured out by doing that. My last entry index is going to be the index of the last element in my log, which is this. And so I can slightly simplify the code by doing that. And then I'm just going to straight up implement the log order up to datedness relation test, whatever it's called. This is, yeah, so the condition is written down here. Can I easily write this down? It's gonna get a bit verbose, but meh, I think I'm happy enough to just write it down in the verbose way because um, I don't know. It's simple. It's just verbose, and so having just one really long line does not bother me too much. So listen, the test is as follows. So I need the candidate to be greater than or equal to the voter. So the candidate needs to be greater than or equal to the voter on this test, and the test is later last entry term wins, and if they are equal, longer log wins, and if they are equal, equality is returned. So first we test the term, and the candidate needs to beat me. So prev log prev log term needs to be either strictly greater than mine, or they are equal, and prev log index is greater than, but we are allowing the equality condition as well because it's a non-strict inequality, greater than or equal to my last entry index. So bracket that because and or distribute over each other, I think. You notice prevlog term and prevlog index are undefined, but that's because they come from the Raft arguments, which are where? They are args of type request vote args. Okay, so I can, yeah, the same way I've access to term by typing args.term, I just type in args here. Safe. Yeah, this is undefined for the time being. I'm going to fix that. It's finally detected the error. And args.prevlog term says that it's undefined, but that's because everything's capitalized, isn't it? Because in our RPC fields all have to be capitalized, if I recall correctly. And it's also not called prev, it's called last. Okay, my bad. Prev is actually a different thing. It's like a variable that is sent in append entries. And it's not last. That's why it's called prev rather than last. It's prev, it's previous, but it's supposed to precede the payload, whereas this doesn't precede the payload, it's just the last one in the entire log. So that works pretty fine for me. It's still saying prevlog index is undefined. Yep, should be last log index. So okay, I need to fix this thing that I said I just didn't implement correctly, which is that we need a new type for a log entry. So it's going to be called the log entry type, and it's just going to have two fields. One is term and one is data, or command if you prefer. But I'm going to call it data because I prefer calling it data. Because functionally it is data in the sense of what Raft is doing. The fact that it's command is a bit too specific. Raft could be handling any kind of data, in my opinion. It doesn't affect the internals of Raft, and so I just prefer calling it data because functionally, to Raft, that's what it is. So yeah, straight up, let's just do that. Pick out Raft and define a new struct for the logs, basically. So let's do it here. Type log entry struct, And log entry contains a term which has type integer, as well as the actual data which has type interface. Or if you prefer, command. You see here how it says command and that has type interface. Basically that's the same thing, data and command, but I just prefer data as my terminology. So yeah, exported type because I capitalized the first letter. Get rid of this fucking warning, completely unnecessary warning. And so yeah, log is going to have type log entry. Do I care if this gets redundantly copied a lot? For the time being, no, I don't. But I don't know. I might have to think about. Whether I want it stored by value or by reference in the actual list. I think my neighborhood is just not violent enough anymore. It means it's just been overrun by these like children. I just wanna. It would be cool if I could like buy a fake gun to scare them away. Just like Hans with. I had a friend in school who used to talk about Hans with the shotgun. Whenever the children approached his windmill, he would just poke the shotgun out of the hole in the wall and just get rid of them whenever they were going to steal from his apple tree. Yeah, Friend had a bit of an active imagination, but I quite enjoyed listening to him, to be honest. Come up with all this shit. Spurts just chatted so much shit. So yeah, I don't know if it's log entry or if it should be a pointer to a log entry, but like I don't know. I mean, I think it's immaterial, to be honest. I don't think it's going to make a big difference. So yeah, the other place where this needs to be put is that entries has type log entry, and yeah, that's dealt with all the problems. Another thing that goes into the to-do list. What's gone wrong? rf.log. Oh yeah, I need to append a command. Oh shit! Yeah. Thank God this. That's the thing about the fact that Go is type safe means that you catch, like, strongly typed, means that you catch so many errors before they happen. Like, this would have trolled me in testing it if I had not remembered it. Basically, what's happened is, here where I append to the log, I just straight up appended the command, whereas I should be appending the entire struct. The entire data, term data struct, which I just edited in. So I didn't update my edit to here where I'm appending something that has that type. Pretty much this. And the term is the term that the leader is in when it first receives the instruction to append the command. I remember it said that somewhere. That's the term of the command, that's how it's defined. And that is literally the term that is pulled here where the leader checks its state before appending the command, so that's totally fine. Basically, yeah. That would have trolled me if I'd not. If the static analyzer or whatever Visual Studio Code had not spotted that. So I'm glad it did. So that's it. That's all the problems solved, and yeah, basically this is it. So if the candidates, because it's the candidate sending to the voter is me because I'm handling the RPC from the candidate, the request vote RPC. That's what this function does. It's a receiver. So what's going on is if the candidate's term on the last log entry is strictly bigger than mine, or in the case that they are equal, in that case, if the last log index is greater than my last index, or if they are equal, because this is a non-strict inequality, if all that happens, then the vote is granted. So that's the situation in which voting is granted. What have I done? Copied in the wrong section. Soz. Yeah, so these are the two things that happen when a vote is granted. So that has now been implemented. Yeah, I was going to add to my to-do list, but I just forgot because it popped out of my head because of that error that just turned up. Check if logs should have type log entry array or pointer to log entries. Pretty much solves that. Okay. So am I sure that this is right then? I'm gonna check it against my notes now. So either, first of all, candidate term is greater than voter term, or if candidate's term is equal to voter term, and candidate's index is greater than or equal to my index, then I grant the vote. And that's basically what it's saying here. It needs to be greater than or equal to on this order relation, which is defined as later last entry term log wins, the log with the later last entry term, else just the longer log, which is to say the later last index. Last index of the last entry in the log is equal to the length of the log. In the sense that I'm defining length of logs, it is the array is actually one longer because it has the placeholder 0 value because it's one indexed, but that's all. Not really a problem. And if that happens, the vote is granted, and if it doesn't, the vote is just false. I don't have to specify that anywhere because it's just automatically false. Yeah, that's it pretty much. Pretty sure that has been implemented fine. So I'm going to do a minor test now of the 2A code. Just to make sure I haven't fucked it up with that minor edit to the log entries. Dear, index out of range has happened in request votes. That must have happened here, right? That has to have happened there. God, all these memory addresses that Go is throwing out is just... It's not such a nice language to debug, I have to say. Don't know what's going on here. Well, it says here it's line 42. Yeah, so the first line is the one we care about. Index out of range error. So what's happened? The RF log, my last entry index is defined as the length of the log minus 1. So it is literally the last entry. But the last entry doesn't exist, so the only way that can go wrong is if there is no last entry, which means there is no entry. So I just have to fix that, I guess. I have to initialize logs to basically contain an empty placeholder value. Because these logs are one indexed, and so they have to be initialized to 0 to just contain some crap in the 0 position, and so I need to just sort that out. I'm just going to put in a default log entry, but how do I do that here? Am I allowed to just specify equals a default value in a struct? I think I can do that in Go. Go default value struct. Oh my god. Look at this complication. Make the actual thing unexported, but then make another thing on top of it that just, initializes it correctly. Um, hmm. Hmm. Grrr. Force a method to get the struct by forcing it, basically writing a separate constructor function. You know, this is the type, and then we have a function that just constructs it. Yes, that's what's gonna have to happen, unfortunately. But then again, I can't do that because I am not in control of the code that initializes Raft, a Raft instance. Or maybe I am in control of it, but it just kind of adds dodge. You know, the abstract noun of dodginess gets added to the code when that happens. It just adds dodge. So do you know what? I'm gonna just I've had another idea, which I think is a good workaround, which is I define a type to replace this, basically. So I take a log entry, a list or slice, and replace it with a new type that automatically has something in the 0 position. Or I make sure that the starting function, the function that starts Raft, which is here, this is probably the easiest version. Not start, it's called make, sorry, yeah, here we go. So where it says rf equals, you know, an address to a Raft instance. Yeah, basically, oh right, this is just the rest of the function signature, and then it returns a pointer to a Raft instance. So here it's saying, okay, I make a Raft instance, I fetch its address and assign it to Raft, and so rf is a pointer to the Raft instance. So yeah, I can basically just yeah, these are all default values assignments. So you know, me is assigned to whatever I put me to be. Same for the persister, which I haven't touched yet. Same for the list of peers. So I can just initialize the log to contain well, the log is already initialized as just being an empty log entry thing. So what I'm going to do is just append. I'm going to just append a trivial entry to the log. So I'm going to go this equals append on rf.log of a trivial log entry. Okay. So that extra initialization code means that this functions as a valid one indexed array. So let's test it out. So see, it's good to always test when you can if you make those kinds of changes. What's happened now? Lab gob through an error because oh dear, because this is all passed in a RPC, it all has to be capitalized. Okay, fine, I can fix that. Term and data just needs to be capitalized. And so problems is going to tell me I need to edit that here because I'm referencing term with a lowercase. I'll just do that. And so I'm ready to just test it again. Alright. Alright. Yeah, if it doesn't crash immediately, it's probably fine because I didn't really add in anything. I mean, some trivial tests on logs that basically don't exist because the entire data phase doesn't work yet. So, yeah, it passes. I'll just do one more test for good measure. just bashing random buttons on this keyboard. This keyboard is a nonsense. Yeah, it's what is it, like 12? How did it manage to get identical times? 3.5 and 9.0, and here it managed 3.6 and 8.9. But down to the thousandth of a second, it seems to be the same. That's what? That's what? That must be a massive coincidence. I'm just gonna check it again because I'm morbidly curious. Like, how did it manage to do the tests down to the nearest millisecond to the same? They took the same amount of time. Like, see, this is wildly different because the second test took a lot less time. So look at the third. You know, I've done the same test 3 times in a row. The third time it was 10.109 seconds. The second time 12.560. The first time 12.560. Exactly the same amount of time, first and second try. And this proves it's not. You know, it is random to an extent. So that's crazy, man. That's absolutely mad. That's ridiculous. Okay, that's it. So yeah, I have now implemented this. VoteRequest is now done, right? Hopefully I've done it right, but like, yeah, we'll see how it goes. But basically, yeah, we've looked at last entry terms, later last entry term, and then longer logs. So I have that inequality in place in how votes are granted, and that's pretty much it. So next sesh is pretty simple. I am literally just going to be doing the other 3 bits that I haven't done yet. So 3, 4, and 5, which are write, commit, and out, the actually genuinely harder bits that are going to require a bit more work. Implementing those. So yeah, that's pretty simple. It's a decent note to just leave it on. Yeah, so I don't know when I'm going to stream next. I did say Monday. Seems like a good shout, Monday morning. But I don't know, I'm going to have a think tomorrow about, you know, just my sort of domestic setup and how self-conscious I feel and how things are going outside and that kind of stuff. Because it's just, I've found it a bit off-putting for streaming recently to be doing that. Which is, yeah, I guess it happens sometimes. So what I mean by that is, okay, next session, in principle, it is going to be when I said it's going to be Monday, but like if I find it's too hot or if I find I'm still too self-conscious for whatever reason, I might just chill for like a couple of days and bring it back on Wednesday. Because I want to be really in my best possible mood to make the most entertaining and insightful stream that I can. When I'm doing this, which is the actual hard stuff, the write, the commit, and the out phase. So when I actually get around to doing the cool shit. So yeah, that's it. I don't know what to say, I guess. I am just, next session I am continuing with the implementation, doing the other 3 bits that I haven't done yet. But when I'm going to do that, I'm not certain about. I think in principle still Monday morning, but subject to change, definitely. I'll see how it goes. Well, no worries. Thanks for joining me today. If anyone was around, it's been real. I'm gonna chill now, properly chill off, get off the stream. Oh yeah, and tune into Zelda speedruns. I might even host them actually. Raid them with like 1 viewer or whatever people do. I mean, I don't have any viewers, so doing a raid would probably be a nonsense. But yeah, just generally speaking, that's what I'm going to be watching now when the Wind Waker HD part starts. And so that's Zelda speedruns, no spaces. A Twitch page. That's where I'm going to be. In time for Wind Waker. Majora's Mask I'm probably not going to watch because not played the game. Maybe I want to play it at some point. No spoiler. I don't know. But as it is, it's all cool. It's all sorted. And that's it. That's it for today. Thanks for tuning in. Next sesh, I think it's going to be Monday at 11 a.m. But this, yeah, is subject to change. And I'll just, post updates on my Twitch page. certainly tomorrow evening I'll have decided, I think, when my next stream is going to be. Tomorrow by midnight BST, which is the time I usually have decided stuff. So yeah, thanks for that. And yeah, I'm just continuing with implementing Raft. The part B stuff, all this stuff, continues tomorrow. Tomorrow? Next stream. Soz. Well, that's it. Thanks. Gonna try to recover my personality a bit. To be honest, that's what I want to do. I want to feel more like myself. Cool. See you.